Welcome everyone to Mathematics channel for grade 10 today. Today I am going to show you video for polynomial part 2. Part 1 we have done and today is part 2 here. So let us see what we are going to discuss in this particular part. The topic of the day is a relationship between 0 and coefficient of a polynomial. So today we will be discussing the relationship between 0 and coefficient of a polynomial for linear and quadratic equations. Linear and quadratic polynomials. For linear polynomial, let us see here. Now, suppose we assume that k is 0 of a polynomial. Now, in a linear polynomial, the form is ax plus b. So let us assume that k is 0 of the polynomial. So if we put the value of k in the polynomial, then it should be 0. The value of the polynomial should become 0. So now if the value is 0, then that means ak is equal to minus b here, and that means the value of k is minus b by a. So in other term we can say if k is a 0 of polynomial px, that is ax plus b, then pk is equal to ak plus b is equal to 0. That means k is equal to minus b by a. That means the 0 is minus b by a. In another language we can say the 0 of the polynomial is negative constant multiplied by minus 1 divided by coefficient of x, or in simple form we say it minus b by a when we compare it with the standard form ax plus b. So now let us discuss about the 0 of a quadratic polynomial. See, for a linear polynomial it is very simple. Let us discuss about quadratic polynomial. Now for quadratic polynomial we will assume that, as we have already discussed, that for quadratic polynomial there will be maximum 2 zeros. So let us assume that there are 2 zeros and the zeros are alpha and beta. Again I repeat, this is called alpha and this is called beta. So alpha and beta are 0 of the quadratic polynomial px. Now let us take the standard form of the polynomial. So px is equal to ax square plus bx plus c, where a is not 0. We will not assume a as 0, because as soon as we assume a as 0, then this polynomial, the x square becomes 0 and now it becomes the linear polynomial only. So then we know from class 9 factor theorem that if alpha and beta are 0 of the polynomial, then there exist two factors, x minus a and x minus b, for the polynomial px. Therefore what we can say? We can say ax square plus bx plus c is equal to k multiplied by x minus a into x minus alpha into x minus beta, where alpha and beta are zeros of the polynomial. So here k is there because it is a constant term which is not connected with your this constant term has no connection with the x. That means it is not existing in the any term of the variable x. So it is only constant term, so k is taken. Now if we solve this one, we will solve, after solving this we are getting, and further if we go, we are getting this particular equation. So it is very easy it does not require any explanation for that. So now if we compare the standard form with the equation or the expression that we have derived, there are x square here also, x square here also, x here also, constant term here also, and constant term here also. So now comparing the coefficient, now we will compare the coefficient of both the sides, that means x square, x and constant in both the sides. Then what we get? We get a is equal to k, b is equal to minus k alpha plus beta, and c is equal to k alpha beta. These are the value of a, b and c that we get from this particular equation. So this equation gives us three values. We are getting value of a, then we are getting value for b, and we are getting value of c. So now this gives us what this gives. This gives alpha plus beta is equal to minus b by a. Now where is alpha? Alpha plus beta, that is, this one is your comparer part of this. If we take this one, then what we get? Alpha plus beta is equal to b by minus k. B by minus k, and again we replace from here, the value of k is a, so we are getting alpha plus beta is equal to minus b by a. Similarly, from this one and this one, we are getting alpha beta is equal to c by a. That means alpha beta is equal to c by k here. From here we will get k, and the k is substituted with the value a, so alpha beta is equal to c by a. I will just advise you to learn this formula so that you can solve the example later on. Now sum of zeros is alpha plus beta, that is minus b by a. We can tell that it is negative of coefficient of x divided by coefficient of x square. Product of zero is alpha beta, that is c by a, that is constant term divided by coefficient of x square. That means in both the situation, the denominator is coefficient of x square, and in case of product it is the constant term, and in case of sum it is negative coefficient of negative coefficient of x, that is b generally say. So now let us solve a problem. The example is find the zero of the polynomial. Now we have to find the zero of the first. We have to find the zero of this polynomial and verify the relationship between zero and the coefficient. So how to solve this particular problem? Let us go ahead. We have px is equal to x square minus 4. So this can be written as, this x square minus 4 can be written as x plus 2 into x minus 2. Why we are using the formula a square minus b square is equal to a plus b into a minus b. So after using this formula, we are breaking this particular into two factors. Now to find the zero of this polynomial, we will have to equate px to 0. That means now we will have to solve this equation by putting x plus 2 into x minus 2 to 0. How? Now if we put x plus 2 into x minus 2 to 0, then what we will get? Either x plus 2 is 0 or x minus 2 is 0. So if x plus 2 is 0, then we are getting value of x is 2, and if x minus 2 is 0, then we are getting the value of x as 2. So we are getting two value of x, that is minus 2 and plus 2. So the zeros are minus 2 and 2. So now if you find sum of zeros, then what are the sum of zero? These are two zeros, so if we add, we get 0 here, and the product we are getting minus 4. If you multiply both the 0, we are getting minus 4. So this we have, this sum and product we have got in by simple method or the natural method that we are doing. Now we will be using the method that we have obtained now, the formula that we have obtained. So here if we compare x square minus 4 with the standard polynomial, what we get? We get a is equal to 1 and b is equal to 0, c is equal to minus 4. See, coefficient of x square here is a, so a is, here is 1. Now constant term is here minus 4, that is c, so c is minus 4. There is no coefficient of x here, so b is 0. So now if we get sum of 0 is minus b by a, so 0 by 1 is 0, and product of 0 is c by a, that is minus 4. So we are getting, so here is the equation 3 and equation 4, and if we compare the equations, so if we compare 1 with 3, we are getting the same thing, and this sum are 0 in both the type. Either we are using the classic method, or we are using the method that we obtained till now. Similarly, we are getting minus 4. So we can say the formula that we have developed for product and sum for the quadratic polynomial holds. That means it is verified, it is working, so it is holds, that we can say the verification we have done. Let us take another example. Find the 0 of the quadratic polynomial x square plus 7x plus 10 and verify the relationship. So first we will find the root, that means we will find 0. So 0 is, we will just explain, you know how to factorize. So I have broken this one into two part, 5x plus 2, and so what we have taken from this one, we have taken from common as x, and from this one I have taken common as 2. So we have get the factor x plus 2 into x plus 5. So here we are getting x plus 2 and x plus 5 as the product. So now to get the 0, we will have to equate this particular factors by with 0. So now if we equate with a 0, what we get? Either x plus 2 is 0 or x plus 5 is 0. So that means x is minus 2 or x is minus 5. Either x is minus 2 or x is minus 5. Now let's move a little further. That means so zeros are minus 2 and minus 5. So sum is minus 2 minus 5, that is minus 7, and product is minus 2 into minus 5, that is 10. So again let us do equation over here. Now again that equation I have carried over so that we don't have to move backward. Now again if we compare this particular polynomial with the standard one, what we get? We get a is equal to 1, b is equal to 7, and c is equal to 10. So the sum of 0 we are getting minus 7 by 1, that is minus 7, and the product we are getting as 10. So if we compare 3 and 4, again the verification is done. So after seeing these two examples, we can say that if we know the 0 of the polynomial, or if we don't know the 0 of the polynomial, we can find the 0 of the polynomial by this particular formula for quadratic equations. So it holds for quadratic equation 1 or quadratic polynomials only, and not for any other type of polynomials. Thank you for the day. I hope you have acquired a good example, and your concept is clear now. Good day.